Hello. In previous video, we saw northwest corner method where we had to allocate the allocation from north corner side, which means from left top to right bottom. Today we will see LCM method. LCM is least cost method, also called as minimum entry cell method, where we allocate the uh, allocation where the cost is least, means the lowest. This is the second method of transportation. Now we'll proceed with first question. We have here 5 rows and 6 columns. First is destination 1, destination 2, destination 3, destination 4 and supply. Factory 1, factory 2, factory 3 and demand. Question: the costs for transportation we have is for F1 D1 6, for F1 D2 is 4, for F1 D3 is 6, for F1 D4 is 6 and supply is 80. Now for F2 D1 is 5 and for F2 D2 is 2, F2 D3 is 3, F2 D4 is 5 and supply is 90. Now for F3 D1 is 4, F3 D2 is 1, F3 D3 is 2, F3 D4 is 4 and the supply is 80. Demand is 50, 40, 70, 90 and the third. So the first step is, it is similar to the northwest corner method. It is similar to the northwest corner method where we have to check whether the demand is equals to supply or not. So demand is 50, 40, 70 and 90 and supply is 80, 90 and 80. So we have to add demand and also supply and we have to see whether it is equal or not. So 50 plus 40 is 90 plus 70 is 160 plus 90 is 250. Here 80 plus 80 is 160, 160 plus 90 is 250. That means we can proceed with the sum. Now we will draw the matrix table. Where we have 5 rows and 6 columns. We have destination 1, destination 2, destination 3, destination 4 and destination 5. Here we have supply. Here demand. We have factory 1, factory 2 and factory 3. As in NWCM method I showed, we have to write the costs in the smaller box. We have 6 here, 5 here, and 4 here, and 50 as demand, 4 here, 2 here, 1 and 40, 6, 3, 2 and 70, 5, 4, 6, 5, 4 and 90. Oh, we don't have destination 5. We just have destination 4. We have only destinations 4. As we saw in the questions, there are only 4 destinations, and supply is 80, 90, 80, and the total is 250, which means demand is equals to supply, and we can proceed with the question. Now, for allocation, what we should see is we have to see which one has the lowest cost here in the matrix table. We will not see supply and demand, we'll just see the cost and we will allocate which has the lowest cost, which means we have here 1 as the lowest, which is in F3 D2. Here 1. So how much can we allocate here? Only 40, because demand is 40 and supply we have 80, but only 40 can be allocated because maximum allocation only 40 can be done. So we will allocate 40 here and we cancel this. This becomes 0 and this becomes 40, and we cancel this column out. Now, to do the second allocation, we have to see the lowest cost again. And now we have to ignore the D2 column. And other than that, we have to see from D1, D3 and D4 which one has the lowest cost. So we have here 2 has the lowest. Here how much can we allocate? Only 40 can be allocated because supply can be done is only 40. So 40 we allocated. Here it becomes 0 and 70 becomes 30. Now if the F3 row has become 0, we will cancel this out. Now we have to ignore F3 row and D2 column, and we have to see the lowest cost from F1 and F2 row. Which is the lowest one here? It is 3, which is in F2 D3. How much can we allocate here? We have 30 demand and 90 as supply. So we can only allocate 30 here. So we will allocate 30. So here this becomes 0 and here 90 becomes 60. And this column gets cancelled out. Now we have to see from D1 column and D4 column which is the lowest, and we have to allocate. We have here 5 in the D1 column and 5 also in D4 column. Now what we have to see is where the maximum allocation can be done, because 5 and 5 both are least one. So we will see here where the maximum allocation can be done. Where can be done? Here we have 50 as demand, here we have 90 as demand, but we have supply as 60. So if we take D1 F2 column 5 here and we allocate 50 here, we can get we can allocate only 50 here because the demand is only 50. But here if we see F4, F2 D4 in this 5, we can allocate total 60 because we have supply as 60 but demand as 90. So we can allocate 60 here. So we will allocate 60 because we have to allocate maximum allocation, maximum cost possible. So we allocated 60 here. This becomes 30 and this becomes 0. As it is 0 here, so we will cancel this row. Now we are remaining with only D1 F1 and D4 F1. Here, which is the lowest, we have 6 and 6 both the sides, but we have to see where the maximum allocation can be done. Where can be done? 50 or 30. 50 is the maximum here demand. So we will allocate D1 F1 first. So 50, we did allocation here. We cancel this out. It became 0. And this here, it became 30. Now we will cancel this column. Now here only 1 is remaining, which is 6 in F1 D4. Now we have to allocate here 30 because we have demand remaining as 30 and supply as also remaining is 30. And this becomes 0 and this also becomes 0. We cancel this row. Now we have to find out basic feasible solution. How we have to find, how we found out basic feasible solution for NWCM method? We multiplied cost into allocated cost. So here for basic feasible solution, which is total transportation cost, we will multiply 50 into 6, which is in F1 D1, plus we'll multiply F1 to D4, which is 30 into 6, plus we'll add F2 D3, which is 30 into 3, plus F2 into D4, which is 60 into 5, plus F3 into D2, which is 40 into 1, plus F3 into D3, which is 40 into 2. We have here, after multiplication, we'll get 300 plus 180 plus 90 plus 300 plus 40 plus 80. After, now we have to add this 300 plus 180 plus 90 plus 300 plus 40 plus 80. We have total transportation cost as 990 rupees. Now we also have to check whether it is non-degenerate or not. How will we do that? The formula for checking non-degeneracy is m plus n minus 1. M is what? The factory. How many factories are there? We have 3 total factories. So M is 3 plus N is how many destinations are there? We have totally 4 destinations. So which is 4 minus 1, and it should be equals to the 6 allocations we have, which is in F1 D1, F1 D4, F2 D3, F2 D4, F3 D2 and F3 D3. We have totally 6. So it should be equals to 6. which means 4 plus 3 is 7, 7 minus 1 is equals to 6, which means it has the required amount of allocations, which means it is non-degenerate. Now we will solve one more question of an LCM, which is least cost method. We have question has again 5 rows and 7 columns. So here we have destination 1, destination 2, destination 3, destination 4 and destination 5. We have 5 destinations here and supply, and we have factory 1, factory 2, factory 3 and demand. We have 70 in F1 D1, 8 in F1 D2, 40 in F1 D3, 60 in F1 D4, 30 in F1 D5 and 10 as supply. We have 40 in F2 D1, 30 in F2 D2, 70 in F2 D3, 20 in F2 D4 and 40 in F2 D5, and the supply is 30. We have 19 in F3 D1, 30 in F3 D2, 50 in F3 D3, 10 in F3 D4 and 70 in F3 D5, and the supply is 20 here. Demand is 5, 7, 8, 14 and 6. Now the first step is we have to check whether demand is equals to supply or not. Then only we will proceed with the answer. Here we have 5, 7, 8, 14 and 6, which is 5 plus 8 plus 7 plus 14 plus 6 is equals to 40. It is 16 here. It's not 6, it is 16. We have 5 plus 7 plus 8 plus 14 plus 16 is equals to 50, and here 30, 40, 50. Here this is 60. Oh. Here this is 20. So 20 plus 10 is equals to 50, which means we have demand is equals to supply. So we can proceed with the answer. As this is the least cost method, we will have to find the cost which has least and start allocating there. Before that, we have 5 rows. and 7 columns. We have here destination 1, destination 2, destination 3 to destination 5 supply. We have 3 factories, and here we have demand. So as usual, the costs will be written in the small boxes inside the bigger one. We have 30 here, and the supply is 10. We have 40 here, and while solving the answer itself, we should like see which is the lowest cost, because we're writing the cost here. So here only if we identify which is the lowest cost, then it becomes easy for us to solve problem. After that we don't have to like sit and search for which is the lowest one. Just the suggestion. 5, 7, 8, 14, 16, and we, as we already calculated, the demand is equals to supply, which is 50. Now we have to see which one is the lowest. Which one do we have as the lowest? We have F1, D2 has the lowest cost, where we can allocate only 7, because demand is 7 and supply is 10. So we can allocate only 7, the maximum allocation. Now when the demand fully it is utilized, so it becomes 0, and here supply becomes 3. Now the column gets cancelled out, D2 column. Now we have to move on to the second lowest cost, which is 10 here. So we will allocate here, but how much can we allocate? 14 or 20? 14 is the least. So we can allocate only 14 here. So when we allocate, we get demand as 0 and supply as 6. Now when the demand is 0, that means the D4 column gets cancelled out. Now we have to find the third lowest column, lowest cost. Which one do we have? We have 19, that is F3D1 as third lowest cost, which is in that how much can we allocate? We have demand as 5 and supply as 6. So how much can we allocate there? We can allocate only 5. So here when we allocate F3 D1, full 5 is allocated, so we get 0 here, and this becomes supply becomes 1. Now we have to demand as 0 in D1 column, so we have to cancel the demand column out. So we are only remaining with 2 columns, that is D3 and D5 column. Now from here we have to see the lowest cost. We have to ignore the cancelled out columns. So here in D3, D5 column, the lowest cost we have is in F1 D5, which is 30. So how much can we allocate there? We have supply as 3, but we have demand as 16. But we can only allocate 3 here. So the demand becomes 13 and the supply becomes 0. As the supply becomes 0, we have to cancel the F1 column out. Now we are remaining with only F2 and F3 row and D5 and D3 column. So we have to see the lowest cost in these two columns, D5 and D3. Which one we have lowest? we have 40, that is F2 D5 as the lowest. How much can we allocate there? We can allocate only 13. So when we allocate 13 here, the demand becomes 0 and the supply becomes 7. Now, as the demand became 0, here we have to cancel the D5 column out. Now we are only remaining with D3 column with 70 and 50. Now which is the lowest here? Here we have 50 as the lowest. So we will allocate. How much can we allocate there? Only 1, because supply is 1 and demand we have is 8. So only 1 we can allocate. Then the demand becomes 7 and supply becomes 0. So we have to cancel the F3 column out. Now we are remaining only with the last cost, which we have 7 in the supply and 7 in the demand. That means we have to allocate 7 here, which means we have properly done the question and we have utilized both demand and as well as supply as well. So we cancel the column and row out. Now we have to find out the basic feasible solution. How we do that? We multiply cost into allocated cost. Basic feasible solution, which is total transportation cost, is equals to 7 into 8 plus, which is in F1 D2, 3 into 30 F1 D5 plus F2 D3 7 into 70 plus F2 D5 13 into 40 plus F3 D1 19 into 5 plus F3 D5 1 into 50 plus F3 D4 14 into 10. So by multiplying we get 7 into 8 as 56 plus 3 into 30 as 90 plus 7 into 70 as 490 plus 13 into 40 as 520 plus 19 into 5 as 95 plus 50 into 1 is 50 plus 14 into 10 is 140. So when we add all this, 56, 90 plus 490 plus 520 plus 95 plus 56 plus 90 plus 490 plus 520 plus 95 plus 50 plus 140 is equals to 1441 rupees, which means the total transportation cost for this problem, which we did in least cost method, is 1441. Now we have to check the degeneracy or non-degeneracy. So to check whether it is degeneracy or non-degeneracy, we have the formula, which is m plus n minus 1, which should be equals to the total number of allocations. How many allocation we have here? 1, 2, 3, 4, 5, 6, 7. We have total 7 allocations. Now, how many m we have? M means the total number of factories. We have totally 3 factories. How many n's we have? N is total number of destination. We have totally 5 destination and minus 1, which is equals to 5 plus 3 is 8, minus 1 is 7, which is equals to 7. That means this question has required amount of allocations, which means this is non-degenerate problem. Now we finished two types of sum, which is LCM method and NWCM method, northwest corner and least cost method. Now the third type will be Vogel's approximation method, which is VAM, VAM, Vogel's approximation method. Now how we go about that is we have VAM. Vogel's approximation method. In this method, we have to find out similarly the transportation cost as well. But in this method, we uses different type of finding out the cost where in this we use penalties, and with that we find out the transportation cost. So what does penalty means is, in the given question, in every row and every column we have to choose the lowest cost uh, uh, lowest cost of every row, that is two lowest costs from every row and every column, and we have to write, and in that we have to choose the maximum penalty, and with that the corresponding row or column in the maximum penalty corresponding row or column, we have to choose the lowest cost and then start allocating. But after allocation we have to find out the penalties again for the second allocation. So we have to go on till we allocate the demand and supply fully. Then uh, we do the normal calculation as finding out the transportation cost by multiplying the cost into the allocated cost. So the question is, we have 5 rows and 6 columns. Here we have 4 destination, D1, D2, D3 and D4, and supply. We have 3 factories, F1, F2, F3, and here demand. The question we have is 1, 2, 1, 4 for F1 D1 1, for F1 D2 2, for F1 D3 1, and for F1 D4 4, for F2 D1 3, for F2 D2 3, for F2 D3 it is 2, for F2 D4 it is 1, then for F3 D1 it is 4, for F3 D2 it is 2, for F3 D3 it is 9, for F3 D4 again it is 9. And the supply is 50 for F1, 20 for F2, 30 for F3. Demand is 40 for D1, 20 for D2, 10 for D3 and 30 for D4. Now what is the first step? What we did in LCM and NWCM, we saw whether the demand is equals to supply or not, because only when the question is balanced, then only we can proceed with the solution. So as we can see, we have 40, 20, 10 and 30. When we add this, we get 60, 70 and 100. And in supply, we have 50, 20 and 30, which means we have totally 100, which means the demand is equals to supply and the question is proper, and we can move ahead with the solution. So for the solution, now we have to draw the matrix table for the solution. Here it is little bit different from the LCM and VAM. In LCM and VAM we drew the same matrix table, but here it will differ little bit. But here we add a few more columns and few more rows for the penalties. It is not necessary that we have to add it, but if you do with adding rows and columns, it becomes easier to identify the penalties properly and not getting confused. We have here five rows and six columns. And we have demand, supply, and here we have demand. Here as usual, destination 1, destination 2, destination 3 and destination 4, and factory 1, factory 2 and factory 3. As usual, we write the cost in the smaller box, which means we have to write here 1, 2, 1, and here it is 4, and the supply is 50 for F1, 20 for F2 and F3 is 30. Now the second row we have 3 as the F2D1, 3 as the F2D2, 2 as F2D3 and 1 as F2D4. Then for F3 we have 4 as F3D1, 2 as F3D2, 9 as F3D3 and 9 as F3D4. Then we also have demand here 40, 20, 10 and 30. We also saw that demand is equals to supply. Now we will draw the penalties rows and columns. We have, for time being, we will draw just 5 or 6 rows and columns. Later on, if we need, we can add on. So now how we have to go about this? As I already said, we have to look for the lowest costs in the each row as well as in each column. So which one we have here in the F1 row, the lowest cost as is D1 as 1, F1 D1 and F1 D3 as 1 as well. So the difference between these two is 0. So we will write 0. Now in the second row we have 2 and 1 as the lowest costs. So we will write the difference, which means 2 minus 1 is 1. In the third row, we have 4 and 2 as the lowest costs. That is in F3D1 and F3D2, which means the difference of these two is 2. Now we have to check the column also. We have to do penalties for columns also. So here in F1 D1 we have 1 and F2 D1 we have 3, which means 3 minus 1 is 2, which is the lowest difference between the two lowest costs. In D2 column we have 2 and 2 as the lowest cost, which means the difference is 0. In D3 column we have 1 and 2 as the lowest costs, which means the difference between them is 1. Now in D4 column, we have 1 and 4 as the lowest cost, which is in F2 D4 and F1 D4, which is the difference is 3. Now we have to see in these penalties which has the highest penalty. We can see that 3 is the highest penalty here. So in that column, we have to see which has the lowest cost. Which one has the lowest cost here? We have F2D4, 1 as the lowest cost. So we have to allocate in 1. We have to start allocation in 1. So how much can we allocate here? We can allocate only 20 here because we have supply as 20 but demand although it is 30. So demand gets 10 and supply becomes 0. So now we have to cancel the F2 column out. Now again for the second allocation we have to find out the penalties. Now when we are finding out the penalties we will ignore the F2 row. So for the second penalty, second allocation, the second penalty row and column will be the difference between the two lowest costs again. So in the F1 row, we have 1 and 1 again as the lowest cost. So it becomes 0. F2 we don't have anything, so it becomes nil. Then F3 we have 4 and 2 again as the lowest cost. That means it becomes 2. Now moving on to the row wise, column wise, we have D1, F1 D1 and F3 D1 as the lowest costs here. That is 1 and 4. That means the difference between them is 3. In the D2 column, we have 2 and 2 as the lowest, which is in F1 D2 and F3 D2, with the difference between them is 0. Then in third column we have F1 D3 1 and F3 D3 9. So the difference between them is 8. Then in the D4 column we have F1 D4 and F3 D4 as 9 and F1 D4 as 4. That means the difference between them is 5. So in the second penalty row and column, which is the highest here, we can see that 8 is the highest in D3 column. So now we have to see the lowest cost in D3 column. We have lowest cost as 1 in D3 column. So we will allocate here in F1 D3. So we have demand as 10 and supply as 50. So we can allocate only 10 here. So demand becomes 0 but supply becomes 40. Now we have to cancel the D3 column out as demand became 0. Now again for the third allocation we have to go again with the penalty. Now for penalty for F1 row again it is first lowest cost is 1 and second lowest cost is 2. So that means the difference between them is 1. Now the second row we don't have anything, it is nil. Then F3 row we have first lowest cost as 2 and the second one as 4. That means the difference is 2. Then in D1 column we have 1 and 4 where the difference is 3. In D2 column we have 2 and 2 again, which means the difference is 0. In D3 column we can't do anything, it is nil. In D4 column we have 4 and 9 as the difference, and the difference is 5. Now in the third penalty row and column, which one is the highest here? We have 5 has the highest. So we will look for the lowest cost in D4 column. We have F1 D4, 4 as the lowest. So we will allocate here in F, F1 D4, which means we can allocate only 10 as the demand is 10 and supply we have is 40. Now it will become 30. Then the as the demand becomes 0, we will cancel this column out. Now for the fourth allocation we have to find out the penalties again. Now we kept as mm, now we can only see the penalties from the D1 and D2 column and F3 row and F1 row, and we have to ignore D3, D4 and D4 column and F2 row. So penalty for F1 row is 2 minus 1 is 1. The second row is nil. And F3 column we have 4 and 2 as the lowest cost, which means the difference is 2. Here in D1 column we have 4 and 1 as the lowest cost. That means uh, difference is 3. In D2 column we have 2 and 2, that means 0 as the lowest cost. Rest all columns it is nil. Now in these penalties, which is the highest, we have 3 has the highest here. So we have to look for the lowest cost in D1 column. We have F1 D1 as the lowest with 1 as cost. So we will allocate here. How much can we allocate here? We can allocate only 30 because supply is only 30 here. Demand, although we have 40. So we allocated 30 here. Now the demand became 10 and the supply became 0. So we will cancel the F1 row out. Now we are remaining with only F3 row, which is 4 and 2. We can't do anything with the columns. So the difference in F3 row, that is 4 minus 2 is 2, and here in the in this the lowest cost is 2, which means first we have to allocate in the F3D2 and then we have to go for F3D1. So here how much can we allocate? We have supply 30 and 20 as D2. We can only allocate 20 here. Now demand became 0 and then the supply became 10 here. So we cancel the D2 column out. Now the last one remaining is F3D1 where we can allocate only 10 as demand is also 10 and supply is also 10. So this gets cancelled out and this also gets cancelled out. We are remaining with nothing as supply and demand is fully utilized. So Now to how to find out the transportation cost here. It is similar to the VAM and LCM method where we used to multiply the cost and allocated cost, which means here the cost and allocated cost, here it is, that means total transportation cost or um, basic yeah basic feasible solution is equals to 30 into 1 plus, which is in F1D1, 10 into 1, which is in F1D3, plus 10 into 4, which is in F1D4, plus 20 into 1, which is in F2D4, plus 10 into 4, which is in F3D1, plus 20 into 2, which is in F3D2. So how many total allocations we have is 1, 2, 3, 4, 5, 6. We have 6 allocations, 1, 2, 3, 4, 5, 6. Yes. So which means after multiplication, we get 30 into 1 as 30, plus 10 into 1 as 10, plus 10 into 4 as 40, plus 20 into 1 as 20, plus 10 into 4 as 40, plus 20 into 2 as 40 here. Which means when we add this up, we get 30, 40, 40 plus 40, 80, 80 plus 20, 100, 140 and 180. We have rupees 180 as the total transportation cost. And now we have to check the non-degeneracy part. We have to see the formula m plus n minus 1 should be equals to how many allocations we have? Totally 6 allocations we have. 6 allocations. So which means the m's are factories, total number of factories. We have 3 total number of factories. Then the n's are the destinations. We have totally 4 destination minus 1. It should be equals to 6, and which is equals to 6. That means the question is non-degenerate, which means it has the required amount of allocations.